In the last session, we introduced SCSI, ISCSI, FC, FCOE. In this lesson, we will study the content of the third and fourth sections together. The origin of SAS is due to the fact that the telecommunications bus has reached its peak, reaching the bandwidth limit. SAS is a serial connection, SCSI. In addition to SAS, serial bus protocols also include FC, InfiniBand, ISCS. Each of them has its own advantages and disadvantages. Next, we will mainly introduce the SAS protocol. SAS is the serial standard of the SCSI bus protocol. The serial interface structure is simple and supports hot plugging, and its transmission speed is fast and the execution efficiency is relatively high. Generally, larger parallel cables will cause electronic interference. The SCSI bus structure can solve this problem. At the same time, the cable structure of SAS saves space, therefore improving the heat dissipation and ventilation capabilities of servers using SAS hard drives. SAS adopts a point-to-point architecture. Currently, its transmission speed can reach 12 Gbps or even higher, and it supports full-duplex working mode. The SAS standard divides the SAS architecture into 6 layers from low to high. Each layer is responsible for certain functions. The sub-management layer mutates hardware, such as cables, connectors, transceivers, etc. The PHY layer includes the lowest level protocols, such as encoding schemes and power supply, slots, sequences, etc. The link layer describes how to control the connection management of the PHY layer. For the port layer, it describes the interface between the link layer and the transport layer, including how to request, interrupt, how to choose to establish a connection, etc. The transport layer defines how to encapsulate all transmitted commands, statuses, data in SAS frames, and how to decompose these SAS frames. For the hard application layer, it describes how to use SAS details under different types of applications. Compared to SAS, the most important improvement of a SAS is SAS uses a serial communication method. It allows multiple data paths to communicate with each device at full speed. Therefore, it can provide higher throughput and make higher performance in the future possible. In addition, 4 narrow ports can be bound into a wide port. Similarly, this can also increase throughput. SAS uses a full-duplex communication mode. Full-duplex is bidirectional communication, so it is not one-way. Traditional parallel SAS can only communicate in one direction. When a device receives a data packet from parallel SAS, if this device needs to respond to this data packet, it needs to establish a new SAS communication link after the previous link is disconnected, then establish a new SAS communication link. But SAS can communicate bidirectionally. Each SAS cable has 4 cables, 2 inputs, 2 outputs. SAS can read and write data simultaneously. This full duplex data operation. It can also improve data communication efficiency. The SAS structure uses expanders for interface expansion. It has very good scalability. It can connect up to 16384 disk devices. The interconnection device in the SAS domain, it is similar to an Ethernet switch. Through the expander for cascading, it can increase the number of terminal device connections. Each expander, it can connect up to 128 terminal devices or 128 expanders. The SAS expander, equipped with an address routing table in the middle, it records the addresses of all SAS drives. But in actual use, because of bandwidth reasons, the terminal devices connected by the expander actually less than 128. Our SAS domain, it is composed of several parts. One is the SAS expander, one is the terminal device, the last one is the SIS connection cable. Through the previous introduction, generally 96, that is 4 hard disk frames with 24 hard disk slots, form a loop. For the SAS cable interface, when the SAS cable single channel is 6 GB per second, we call it a mini SAS cable. Now the single channel speed has increased to 12 GB per second. the corresponding SAS cable is also called a high-density mini SAS cable. Next, we introduce another protocol, SATA. SATA is known as Serial ATA. It is a computer bus. Its main function is to be used for design transmission between the motherboard and mass storage devices. SATA is not a simple PATA, but a completely new bus structure. SATA refers to parallel APA. SATA has stronger error correction ability and stronger anti-interference ability than PATA. Regarding a key difference between SAS and SATA, at the physical layer, the SAS interface and SATA interface are fully compatible. SATA drives can be used directly in a SAS environment. In terms of interface standards, SATA is a lower standard of SAS, therefore, SAS controllers can directly control SATA hard drives, but SAS cannot be used directly in a SATA environment because SATA controllers cannot control SAS hard drives. Next, we introduce the two protocols of the fourth section, PCIe and NVMe. PCIe is a high-performance, high-bandwidth serial communication interconnection standard. It is an important branch of the computer bus. It now uses a concept and signal standard of PCIe programming and has built a faster serial communication system standard. PCIe is only used for internal interconnection. Since PCIe is based on the existing PCIe system, it only needs to modify the physical layer without having to modify the software layer to convert the existing PCIe system into a PCIe system. So why use PCIe? Firstly, the traditional PCIe bus has several characteristics. The first one is that the bus structure is relatively simple, its cost is relatively low, and the design is simple. This is its advantage. The parallel bus cannot connect too many devices. The bus's scalability is relatively poor. This is a disadvantage of the PCIe bus. Moreover, when connecting multiple devices, the effective bandwidth of the bus will decrease and the transmission rate will slow down. So in order to solve these problems, in 1991, Intel first proposed the concept of PCIe. The PCIe standard was established with a view to the future while continuously increasing storage capacity and improving performance. It uses a layered protocol to keep the driver compatible with current PCIe applications, simplifying the transition process from PCI to PCIe. The structure of the PCIe protocol is mainly divided into 4 levels: physical layer, data link layer, transaction layer, application layer. In the PCIe bus architecture, the physical layer, it mainly determines a physical characteristic of the bus. In the future development process, it can further improve the performance of the PCIe bus by increasing the speed and changing the encoding and decoding. The important role of the data link layer is to ensure the correctness and reliability of the data packets transmitted by the PCIe bus. It will check whether the data packet encapsulation is complete and correct, and whether the serial number or redundant transaction code is added to the data and sends it to the data protocol. It is also a designated standard and a designated protocol. This protocol can access flash storage through the PCIe bus. This bus supports many parallel command queues, so it is much faster than hard drives and traditional flash architectures that are limited to a single command queue. The advantage of the NVMe protocol can be seen through its protocol stack. On the left is the SAS protocol stack, on the right is the NVMe protocol stack. If we compare from the software protocol passing level, the difference in protocol interaction technology for data writing between SAS and NVMe all-flash arrays is quite large. A complete host data write request, if using the SCSI protocol of the SAS backend, requires 4 protocol exchanges. From the application layer to SAS, then to the target device's SCSI, only then can a data write be completed with these 4 protocol interactions. For NVMe all-flash, it only requires 2 protocol interactions, from the app application layer to NVMe to the target system's NVM. So through this protocol stack, it can be seen that the efficiency of handling write requests is twice as high as that of SAS all-flash. On the transmission path level, SCSIO is from the front-end server through the FC or IP front-end interface protocol of the storage device. Transmitted to the target device's SSD, it has to go through 4 information interaction processes. For NVMe all-flash, it supports end-to-end NVMe interaction. So through this interaction process, it can be seen that the communication interaction of NVMe has been reduced from 4 times to 2 times. Therefore, it will reduce communication latency and improve its transmission efficiency. From what we have learned earlier, therefore, it will reduce communication latency, improve its transmission efficiency. As we learned earlier, NVMe layers are an abstract protocol layer. Its purpose is to provide a reliable NVMe service chain and data transmission. In order to support data center network storage, implement NVMe standard through NVMe over Fabric expansion on the PCIe line, challenge the dominance of SAS in the SAN network. Through this, it's a dominant position. NVMe over Fabric supports mapping NVMe to multiple fabric transport options. These fabric options include, for example, FC, InfiniBand, ROSI network, CCP, and so on. There are 2 types of transport that NVMe over Fabric can choose from. One is using NVMe over Fabric of Remote Direct Memory Access, RDMA. The other one is using Fiber Channel, FC NVMe's, NVMe over Fabric, Huawei's Ocean Store Dorado All-Flash. It relies on NVMe over Fabric to achieve a strong control item of SSD resources, which can provide 32 GFP NVMe and NVMe over 100 G RDMA network design, realized a connection between the front-end network and the back-end hard disk frame. So through this, you can also see the main advantage of NVMe is that it has a relatively high IOPS and it also has a relatively low power consumption advantage. That's all for this lesson, all the content. In this lesson, we mainly learned 4 protocols, namely SAS, SATA, PCIe, NVMe, and also introduced the definitions of these 4 protocols, functions, protocol principles, etc. That's all for this lesson. Thank you for learning. See you next